Okay, here's section 6.4.2, special right triangles, 30, 60, 90 triangles. So I'm going to start off with just letting you know that what we're aiming at is the hypotenuse of our 30, 60, 90 is twice the length of the shortest leg, and the longer leg is root 3 times the shorter leg. So I'm going to draw your attention to the purple triangles. We want to think about the purple right now. Okay, don't pay attention to the tan just yet. The purple is currently a 30, 60, 90 triangle. Okay, and what we're going to do is, as a proof about how long these sides are, what I'm going to do, imagine that I took the length of DC and I simply extended it in the other direction so that these were the same length. And we know that from the ruler postulate. Well, what happens is that if I do that, and I go to the top here and I look at this length right here, this is congruent to itself, and I simply connect these two, right? There's no assumption of angles or anything, but if I just connect these 2 points, these 2 triangles, the purple and the tan, become congruent by side, angle, side, right? Because they share that same side. So what we can do now is say that DC is x length. Well, that means, and we discovered that, and we made it, that, that BD is also x. If we look at the giant triangle, and I can do this in blue, the big triangle itself now is a equilateral triangle. And so if this whole side, whoops, didn't mean to do that. I don't know why that keeps doing that. If the whole, whoops, if the whole side is 2x, right? This is also 2x, and this is also 2x, all these sides. And now let's go into the purple triangle, because now I'm going to ask ourselves, if the hypotenuse of the purple is 2x and one of the legs is x, we can try to figure out exactly how long that thing is right here, right? And we can do that without letting it be y temporarily. And back to the Pythagorean theorem, we know that x squared plus y squared, and just be careful, is 2x all squared. Right? And that leaves us with x squared plus y squared is equal to 4x squared. So don't forget to square the 2 and the x squared. That leaves us with y squared is equal to 3x squareds, because I'm going to subtract this from both sides. And that gives me that y is equal to the square root of 3x squared. And we know that we can separate those. Root 3 times root x squared, and that gives us root 3 times x, and probably better written as x root 3. So there we go. Conclusion for purple triangle, a 30, 60, 90 triangle. If I think about the side opposite the 30 as being x, the hypotenuse will be twice x, and the other leg, we've just now proven, will be x root 3. Right, now we want to ignore the tan triangle and just think about the purple.